Hello everyone. Have a good morning everyone. Okay, so my name is Yogesh Ghorpade. So over here you can see my qualification, my job role, and the location where I'm live. Okay, so today I'm going to today's session for the topic will be subnetting. Okay, so first of all we'll start the definition of subnetting. The practice of dividing a network into two or more networks is called subnetting. Computers that belongs to a subnet are addressed with a common identical or the most significant bit groups in the IP address. So over here I am considering the IP version 4 class. Okay, and over here I am going to demonstrate an example of class C IP address. Okay, so we'll start with the problem. So I hope that all of you understood the definition of subnetting. Okay, so basic will require the subnetting to solve the problems under the networks files such as IP addressing, all that. Okay, so I'll go with an example or the demonstration of class class C IP address, class C IP address. Okay, so okay, so if I'm taking 192.168.0.1 with the wildcard mask of 25. Okay, first of all, what do you understand by the word wildcard mask? So wildcard mask is related with the term called as network bits on. So if the network bits on in the class C address is uh, if I'm counting it's 25, then it will be called as wildcard mask. For example, as we know that the class C will have a reserved of 3 octets for the network and 1 octet for the host. So I will illustrate same thing, the wildcard mask in the problem, so you will understand it better. So this is called wild card mask. Okay, so I will tell you there are 5 steps to solve the problem of subnetting. So step 1 is finding or the converting the IP address into the binary binary format. So the binary format for the IP address is, for the above IP address 192.168 will be dot 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 1. Okay, so over here we can see I am having 4 octets. Okay, this first, this as the second one, this as the third one, and this as the fourth one. Okay, so over here there are 4 octets because it belongs to the IP version 4. Okay, so I had taken this binary format from the IP address. So the if all the bits of these octets are on, the decimal number will be 255. Same thing for the second octet, it will be 255. Same thing for the third octet, it will be 255. And the last octet, which the bits are not on, we'll call it as a special octet, and the decimal number for that will be the conversion of binary into decimal for that number is 2 raised to 7. That gives to me 128. So how did I get it? That is nothing but 2 raised to 7, that is equals to 128 bits. So I will call this as a special octet. Okay, okay, so this was my step 1, right? Now I will go for step 2. So step 2 is finding of host, that is number of host. So the formula for this will be 2 raised to h minus 2 that is equals to 2 raised to first how you'll identify which one belongs to those and which one belongs to the network bits. Over here I will give a one of it, right? The 0 will represent the host and 1 will represent the networks. So over here count the number of zeros. So 1 2, that will be I will show you 1 2 3 4 5 6 7. Okay, so 2 raised to 7, that is equal to 2 raised to 7 minus 2, that is equals to 128 minus 2, that is equals to 126. So the number of hosts is equals to 126. Next step is step 3, number of subnets, number of subnets, that is equals to, the formula will be 2 raised to s. I will tell you why we had subtracted minus 2 from the host formula. So number of subnets is equals to 2 raised to s, that is equals to 256 1, that is equals to 256 minus so formula 2 raised to s, that is equals to 2 raised to number of bits on. So number of bits on are 8 plus 8 plus 8 plus 1, that is equals to 2 raised to 1, that will be equal to 2. So why we had considered 1 bit in the number of subnets? Because it belongs to class C, and as you know that class C, the 3 octets are reserved for 3 octets are reserved for networks, and other last one is reserved for the last one is 1 octet reserved for host. Okay, so that is the reason why we had taken the number of bits on from the last octet. So step 4 will be the block size. It will be about the block size. So block size formula will be 256 minus special octet, 256 minus special octet, that is equals to, so what we got the special octet from the step 1 is nothing but what, 128. So the block size will be 128. Yes. So now step number 5. Step number 5 is nothing but subnet design. So in the problem we had in the problem the IP address given for us was 192.168.0.1. okay, so the first IP address obtained will be the 192.168.0.1. It will be called as a network address, okay, and the 192.168.1 dot, that is 0.2, will be called as the host address, and this host address will go up to 192.168.0.126. this will be my last host address. Okay, and the last address of this block will be 127. Okay, so this will be my, the last IP address will be called as the broadcast address, broadcast address. So in same way or similar way you can go for the second subnet design, that is 192.168.0.128. Same way 192.168.0.129, that will be my first host address. Yes, right. And my last host address will be 192.168.0.8.254, and the last IP address for the blocks for this block will be 192.168.0.255. so that will be called my, yes, broadcast address. This will be called my network address. This will be called my first host ID, and this will be called as my last host ID of this subnet design. So over here I can say this is my second second subnet, and this was one my okay, here first subnet. Yes, so I'll color it the first subnet. So this is my first subnet, and the second subnet will be starting from here. The address is given. I'll mark it in different color. Okay, two subnets. Now I will verify my steps for the provided problem. Okay, the step 1, yes, the verification will be the wildcard mask. Okay, the total number of wildcard masks given over here is 25. So you have to check the number of bits on are 25 or not. That will give me the wildcard mask calculation. Yes, it's 25. Number of hosts, step number 2, it's equal to 126 or not. So go in one of the subnets, you will get the host address, first host address and the last host address. That's starting from 2 to 126. To 2 to 126 will give me the total number, that is 126. Y minus 2, that is the first address was reserved for the network address, and the second last was reserved for the broadcasting address. So in step 3, number of subnets is equal to 2. So as a result, what you obtained was the first subnet, which is marked by the yellow color, and the second subnet, which is marked with the another color. So over here we get two subnets, and the total calculation made is up to 255. Okay, so it will start from the given IP address, and obviously it will end to 255. It was a class C IP address, therefore the host octet will be the last one, and it will end by 255 only. Okay, so this was the problem from class B. If any query, you can mail me on this mail ID. Thank you.